How is the going?
The Jacob's ladder?
Yeah, you built that yesterday.
Actually, it was great. We yesterday we used an electrical display called the Jacob's ladder in a segment about voltage. And actually, we had a bunch of questions about how we built it. So we're going to take you behind the scenes.
Look at that. It's working really well. You must have been fiddling with it.
Well, you know, everybody needs a hobby. How we made it before the show yesterday, or at least stumbled through the process. Can we roll the video, please?
Let's see that tape.
Let's see this. All right, here we have is insulating, because I hate lighting myself on fire. Now, we want to remind you, like it says in the red thing across the screen, the bottom there, do not do this. We're actually taking the paint off the electrodes, which are common, ordinary
coat hangers.
That's
what they look like, yeah.
Okay, here we go. More insulating. They must have fast-forwarded this, because I know my hands don't move that fast, ever.
Look at you go. You're moving.
Well, the problem was after we insulated all of this, this is the high-power wire. This is basically a high-voltage cable that you connect between the transformer and
it's not plugged in now, am I right?
It's not plugged in now. If it was plugged in now, I would be dead.
Okay.
Yes.
Kids, don't do this, really. This is something maybe you get your teacher to do with you or something. It's very, very dangerous.
Really dumb uncle that's well over the age of 21. Russ looking on in fear.
Is that how you learned?
We're actually firing it up here. We're just starting to get a spark. What was happening there? Yeah, what happened, we couldn't get it to work properly. It was burning its way through the wood at the base of the electrodes instead of up through here. So you can actually see the scorch marks with that one shot.
So how'd you fix that?
Well, we actually isolated it farther, and we insulated both the posts and the cables.
Can I ask you one science question?
Sure.
I understand why it jumps the gap, because you've got electricity on either end, and it's close enough that it can jump the gap. Why does it go up?
My understanding, my knowledge, I'm going to get yelled at by physics teachers all across America, but basically you end up creating a plasma stream that's burning through the air right there. As it heats up, it rises.
Oh, I get it. Heat rises. And then it falls off the edge and a new one starts at the bottom.
As it gets so far apart at the top that it can no longer jump the gap there.
How come it goes up when you jiggle it?
You know, a lot of things.
No one knows.
Family show, Leo.